Okay, when I say we have a rectangular system, I mean that when somebody gives you coordinates 2, 3, what do? You count over 2 and up 3. Your graph paper is set up as a system of rectangles. They're squares, but squares are rectangles. So it's called a rectangular system. Everything is identified in terms of a horizontal and a vertical. We are changing now to a circular system where things will be identified in terms of an angle and a distance. So for example, your ordered pair might look like this, 3, 90 degrees. That means your distance from the origin, now known as the pole, the distance from the pole, like the North Pole, the distance from the pole is 3, 1, 2, 3, and the angle is 90 degrees. Now your points will be identified that way in terms of a distance or a radius. Since it's a circular system, you can think of that distance as a radius from the pole and an angle and standard position. So 2, 30 would be 2 circles out, an angle of 30 degrees. That would be 2, 30. You can imagine that our job is going to be to change from one coordinate system to the other, to move from an xy to an r theta. And that's what those conversion equations are going to help you do, not only in terms of points, but in terms of complex numbers and in terms of equations. So here's what I want to show you that might help you remember. If you just graph this much of the butterfly bow tie, you know already this is x and this is y. We've been doing that forever and ever and ever. This now, if you think of a big circle here, this now is r, and this is theta, the angle and standard position. So things that you have already learned, look at the picture. What's the cosine of theta? If you look at this picture right here, this right triangle, what would the cosine of theta be? What's cosine? X over r. Now, is that new to you? No. I hope not, because months ago you were asked to memorize that cosine equals x over r. Well now, if you look at your conversion equations, it says x equals r cosine theta. Can you see that's exactly the same equation? Just written differently. So this isn't brand new to you. But you must know x equals r cosine theta. And what does y equal? Using exactly the same logic from exactly the same picture, what would y equal? R sine theta. Now, that's 2 of the conversion equations right there, right? There's only 4 of them. What are the other 2? Tangent theta equals y over x. Is that new news to you? That the tangent of theta would be y over x? Is that new? And in fact, you've been doing this all along with your vectors. If you want to know what that angle is, what button do you press on your calculator? If you want to know what theta actually is, second tangent, y over x. That's how you find angle theta. That's how you find this right here, second tangent. And then what's the last conversion equation? Which is the Pythagorean theorem in that triangle. And you just took a quiz over that because on your quiz, didn't you have to find magnitude? And how'd you find magnitude? X squared plus y squared, and you took the square root. So what does r equal? Rx, just like the magnitude that you've been finding. You're going to square that, add them up, square root, and that's how you're going to find r. So tomorrow you're going to walk in, I'm going to say get out a half a sheet of paper and you're going to write down the 4 conversion equations, right? But you already know them. This should not be a big deal for you. Now, how do we use them? Well, let's take our point 2, 3 that I just had up here on the board. Those are what we call rectangular or Cartesian coordinates. Those 2 words are used interchangeably. So we have an X and a Y, and you are going to change that into an R and a theta. In other words, you are going to change that into what we call polar coordinates. So when you see or hear the word rectangular, what pops into your head? Cartesian or X, Y. Those are your variables. When you move into polar, which is the circular system, which is the graph paper that I passed out, when you move into that, then your variables aren't X and Y anymore. Your variables are R and theta. So what you are being asked to do here is take this pair, which is X and Y, and change it into R and theta. And I encourage you to use that picture. Over 2, up 3. That's what we've got here. What's R? This is not confusing for you. What's R? You've done it a million times. Square root of 13. What's theta? This is theta. How are you going to find theta? You're going to say second tangent 3/2, and that will give you an angle. Actually, that was your problem, right? 56.3. Now that is not hard. It's new. You've never seen polar coordinates before, but it's easy. You know how to find them. All right, so let's try one more quickly. Stay with me. The bell has not rung. Change -2, 1 into polar coordinates. So here's X and Y. Change it into polar coordinates. So let's visualize it. -2, 1. What's R? Root 5. That's easy. Now, just as it's always been, and what are you doing?
Me?
Yeah.
I was going to write something out.
Okay, let's pay attention to what's going on here. This is theta. So you're probably going to type into your calculator second tangent 1/2. And that's going to give you this angle right here, which is 26.57. You with me? Then how are you going to get the actual theta that goes in the parentheses here? You're going to take 180 minus that, right? So your answer would be root 5, 153.43 degrees. All right? All right, good job. Okay. Done to around the clock.